it's not so conversational because they itself said like it's powered by ChatGPT, but it just retrieves the result. But the expectation what I said is not yet achieved. So that's what I'm saying. And similarly, during the Gen AI gold rush, right? I think Amazon also released their own conversational AI, which is good enough, but it's not in public review, I guess. Uh, so before that, like, so everyone got the perspective, right? How we are going to travel. So basically, that fellow is saying like, I just want to search something. So I will search some random English or like my own language of describing things, and it should say intelligently search that product to me from the catalog. That's what it says. That's cool. So that's the process. And before that, right? Who has the latest and greatest Samsung S24 or S23 in the room? No one. Oh, cool, man. Uh, okay, so you have that circle to search. Not even, man. Man, they are going so hard on AI in smartphone. You said you are not yet used. Man, you should use it. Yeah, nah, even I don't use it. So now you normally bootload it anywhere actually. You can do it in any smartphone. Okay, so the circle to search. Basically the aspect is if you're going for a market, what kind of product is this? I just want a similar product. You just take a picture or you already have a picture, circle it and it searches it. So basically the way of searching is not conventionally by typing things. So it's basically like image, audio, whatever. So there are multiple mediums. So basically, I give anything, I give pictures, audio, images, anything, it should give me a result from the catalog. So basically I want to make you buy something from the shop. That is important from business, man. So let's jump into the tech part actually. What is multimodal? So basically multimodal means vision and audio and writing, everything. So multiple aspects and multiple formats will be given to a machine. Is not a multimodal. So maybe a question to audience. Okay, so I said like image, right? Do if I send a PNG and JPEG, will it is the same model or it's a different model? It's the same model, or it will two different. Yeah. So basically, there is even a research paper on it because multi-model JPEG is different and PNG is different. But for a human-like understanding, we say classify every image as image. So they are actually two models. So, so before that, man, anyone did a RAG POC or Gen AI POCs want to talk? Because I don't want to talk it again. To anyone want to maybe give a try, man? I know some people do a POC, or I will explain it. So. And that's rude. Okay. Anyone want to talk? Uh, Maybe I can pick someone. Ramki, do you want to talk? Okay. Maybe you can talk, right? Man, don't be me forcing. Dyson, I know. Man, recording and live streaming. So okay, whatever. So cool. So people are a little shy, but fine. Even I am shy when someone speaks and give me the mic. So yeah. So basically, it's nothing but interesting. Like dump all the text, images as embeddings and retrieve it and just beautify with LLM in a shorter note. So basically, you're doing a search for text or a document is making as a vectors and searching it based upon your similarity, ANN, and the LLM just beautifies it. But in multimodal, the game is different because you're not giving image and um, text should be paired enough. So you should store the both the things nearest to each other. So that only if I gave an image and also the text for it, it should smartly retrieve the product. So the multi-model embeddings are different. So we will get into details in further down in the session. So before that, like we talked about search, right? Types of searches. Why not? Okay. So keyword search, you give a search. First, you just thought I want to build a conversational search engine. So before that, before making conversational, we should build, what kind of searches are there. So there are like keyword based search. So basically, you are just from the document, you are just picking up the similar words and indexing it out. So basically, when you do it right, there's something called a sparse vector. So sparse vector is not like your conventional dense vector. Too much terminologies, I know. So basically, in the sparse vector, right? Maybe I can give it hello world, hello everyone. Okay. So hello is repeated 2 times, world is repeated 1 time, everyone is repeated 1 time. So this is the assumed as sparse vector. Okay. So I do have another what to say document. So basically, like let's say hello to the world with a new project. So how the sparse vector will be generated based upon the base vector, right? Let is not even repeated 0, say is 0, hello is repeated 2 times. So basically, from the base, it will make the vectors for the consecutive documents. So that's why it is known as sparse vector. There will be a lot of zeros actually. There will be no actual values. There will be a lot of zeros. So that is the best part of it. Okay. So before going to the search algorithms, right? This is how the sparse vector. There. Anyone worked with Elasticsearch? Ah, cool, man. So, ah, okay. So I thought you, okay, fine. Ah, that will be nice. Want to? That's what I'm just saying. Hmm. They're basically keyword search. And I mean, this, you use BM25 or the older one? Okay. Okay, cool, fine. Okay, so these are very old search algorithms. It has been invented before I am born even, so it's very old. So, but it is very easy to explain. So, I mean, if someone is who up to date knows, there are like even 1 month ago, there is a vector search DB of Quadrant. They released their own algorithm called as BM42. They're saying it's much more efficient and getting a lot of buzz, but I'm not sure how far it is. So let's be honest. So let's go to the basics part alone. So TD-IDF. Okay. So basically, TD-IDF is nothing but, I mean, I even forgot the full form, man. Damn it. Term frequency, document frequency. Okay. Uh, cool. So when you have a document, right? Apple is good for health, banana is good for health. Apple and banana both are fruits. So you have a document, you just put it set, and you have like three statements, and you have to search for the particular word apple. So assume it, you are just searching for a particular word apple. So how the calculation happens is, right? So you have to calculate the term frequency. So from the D1, so apple is good for health. So 1 divided by 5. 5 is nothing but number of words in the app, in the sentence. So 5 words, 1 divided by 5, which is 0.2. So second word doesn't contain apple, so it's 0. Third word. So third word considers apple 1 time, but 1/6 because it has 6 words. So this is how we calculate the term frequency. Now we will go to the calculation of inverse document frequency. Okay. So basically you're calculating by log of 3/2. What is log of 3/2 is nothing but you have like 3 sentences in the corpus and divided by 2. So that's how you calculated it, and you'll get this thing. And you just multiply these two factors to calculate the score. So if I search for an apple, right, the sentence D1 will be retrieved first because it has a higher score, 0.018. So, but you say, damn, it's wrong, man. So both the apple in the first sentence and third sentence have it, but it repeats only one time. So why it is retrieving, making the score as D1 as highest is hmm? Exactly. That's what BM25 eradicates it by normalizing it. So that's it. This is a very complex formula. No one wants to know it, but know it. But let's be honest, man. Even I just, for the purpose of the document, I just put. So when you normalize it, right? I even manually substituted it, maybe for the purpose of the session. So basically, when you calculate it, right, the score of D1 and D3 is same, 0.472 and 0.47, which is correct. So when you search for an apple, so both have the same score, which is perfectly fine, which is good. So there are also other algorithms like SPADE and B42, but it's very complex to understand. Even I don't know, to be honest. So what are the takeaways? Sorry. So memory efficiency, high dimensionality, and you can just skim it to, I will send it anyway. So let's move on. So let's go for the embeddings as usual. Anyone want to speak about embeddings? Hey, everyone knows everything. So I'm just repeating, skimming for the new audience. Very highly interactive audience. I'm appreciating it. So embeddings, when you have a cat, dog, or anything, right? So you make it as a vector. So what is vector in physics? Actually, that is very interesting. We can talk about vector of physics, max, and here. School student, college students, anyone? You said, oh, you're not college student. Okay. You look young, man. Okay, so no one wants to answer what is vector.
Has both the magnitude and distance. Direction, huh?
Same. So, so you can plot it in the three-dimensional space, which has x, y, z. So in so basically in physics, you will say it as x, y, z, and you'll plot it. But for example, if you go into detail, like if you study the electronic magnetics like me, there are like so I don't remember. So x, y, z coordinates, you'll make it like this and plot it in the plane. So that's what it is. So basically different words been plotted here: walking, walked, swimming, swam. So these words has been mapped and based upon the nearest neighbors, right? So we will retrieve it. That's the whole concept of it. So basically in the three-dimensional space, we can plot it whether like realistic cartoon or bird and get the most nearest result. So basically here in the image, right, I saw sparse vector and dense vector. Where you can sparse vector, you can see a lot of zeros. Whereas in dense vector, you can not see any zeros. So that's what it is. So how will you search, right? So basically, you can use cosine similarity search or dot product, or even who is from fresh from the college, there are like cross product and every other things. You can retrieve it, but for now, mostly cosine similarity is being used. So basically, if you have 2 points and you'll get the calculate the angle of it and retrieve it. That's the whole concept. So there's also a game called a Simandal. So basically, you just keep on typing words and guess the word actually. For example, let us play a game. Huh? Do you have time? Okay, cool. Maybe I can show it, man. Okay. So maybe five people can say, what is the word of the day, man? Anyone wants to put a word? Do say some word when random. Damn. Huh? Ah. Even I don't know the spelling, man. I need to copy paste it. I'm pretty weak and dumb. Mhm. Okay, man, it's far. So say it something near. 5 words, man. Let's wrap it up. Apple. Okay. Okay, it's called something near to food or something. Ice cream. Pepper. Okay. Ice cream. You are entering all capital letter. This probably may not of what is you're reading a lot of you're entering a lot of capitalized letters. No. Okay. Okay. I'm already lowercase, right? Okay, man, it is very oh, damn. Interesting. Man, you see, I'm already entering a down case. He's showing me a button down case. Bug phone. Okay. Okay, man, it's cold, cold. Let's wrap it out. Maybe you can play it with when you're bored at night. So, okay, cool. Hmm. Let's move on, man. So yeah, you can play that game, and basically when you retrieve it, right? What is the capital of Canada? So this dense retrieval is not so good. Why I'm saying there's also a downside, right? It will give some random things actually. If you ask from the document, right? If they basically if you give anything, it just gives the nearest search, which is not efficient enough. So that only people started to go for the hybrid search and other things, which is nothing but the re-ranking of both this keyword search and dense retrieval. So we are the topic is not about it, but yeah, even I can share the slide. It's for about it. So let's go about multimodal. We talk. This is where we just stopped it and recontinuing it. What is multimodal embedding? So basically, you just plotted all both images and the text right as a pair inside a same dimension, so that it will be easy to retrieve it. For example, both this text and the image is stored in the same dimension, same Gaussian plane, near to each other. That is the point. Near to each other so that they can be retrieved easily, not far away. Usually they will store it far away, but in the when you put a joint embedding space, right? It's nothing but you'll create something contradict loss and train the embedding, make changes in the embeddings and store it in the same dimension so that it can be retrieved easier. So that is the point. So how will you build a multi-model, man? It's very easy. Take a unimodel, fuse it. So basically, who's very active in this Gen AI space actually? In audience, someone can say, right? So maybe some crazy nerd who just looks at model or for project or something can say a model, right? Maybe Ramki. Maybe some say some models actually LLM models that comes. Okay. Any other thing? Maybe a single model, voice model or from Google, from Microsoft, something. The open source models. A GPT-2, you're saying about two. Okay. Okay, GPT-2. So it's basically a text-based model. So if you give a text, it will reply in text. But I'm giving image also. So you should take some image models actually. Uh, Google Gemini, Gemma or Gemini. Gemma is open source model. Gemini is their own proprietary model. So Gemini is multi-model already. So yeah. If you give a Gemma and this OpenAI, right? They are all are multi-models, so that only you can give a document and chat. For example, if you take any Ramki said GPT-2, right? It's a text-based transformer. So if I want to make it as a multi-model, right? I don't want to too much care. Like I create a clip. Clip is a image encoder. So I take the clip model, image model, and the text model, fuse it, and make it as a multi-model. That's what they do. It sounds simpler, but it has some complex. For example, clip is nothing from OpenAI only. It has been an image encoder which has been used. So yeah. So basically, if you're bored, right? If you want to create multi-model, people actually do it. I'm not saying, I'm not lying it. People, even if you want to create a multi-model, take some text encoder or BART or anything something and create combine with clip or C-clip something like that and create your own multi-model. That will be good. So yeah, I said right, clip and sing clip. So basically, what is clip is happening, right? Clip has both text and image model. So there is text encoders or image encoders. Both will be passed. Both the inputs will be passed in, and basically you will have a pairing matrix like this. So where it like, for example, they pass it. For example, I1 and it's a pair. For example, I1 is an image that is parallelly for the T1. So that's the correct match. So that only is current encoder. Whereas I1, I2, I3, I3, it's a negative end. It's not a good match. So that's what they say contradict loss. So that's how they train it. So first they contradictory pre-train it, like making like a matrix, and now create a data set classifier and pass it. This is how a very, very high level architecture will be for a clip or creating a multi-model. So this is just a simple example, and it is very nice. For example, sing clip, right? Instead of contradictory clause, they use sign order loss. Okay, so basically the same model, but they use a different loss function, sign order loss, so that it is much efficient. That's what the difference are. And so let's do a multi-model search. Okay. um, okay, let's do a multi-model search using Blip2 and Lewis. Okay. Uh, Lewis is nothing but a library from. Okay, I think people are short. We are short of time, so we can skim it faster. So Lewis is nothing but a single Salesforce library, which is for the vision transformers we use. So I used it because it is very easy to extract the features, actually image or text features from the inputs will be, it's very easy. So you can, anyone can do it. No need to just load it from the hidden layers, etc. So that will be easy. So maybe I will give the share the repository. You can run it in your free time. So it's not a rocket science. So this is a very high level architecture for Blip2. Blip2 is little bit conversational compared to Clips. Okay. So they have two parts, and the innovation part is nothing but queue former. Okay. Queue former, and where they freeze a image encoder, and in this queue former there are multiple queries that will be matched with the images. So that's what it is. And I don't want to dig deeper on it. So let's go for the demo part. Give me a minute. Okay, let me open it. Cool. Probably I will not run because it will run for a longer time, like 10-30 minutes. So I just don't want to. So I'll just give you the glance and important parts. Skim it to the code base. So okay, not sharing. Damn. Okay, cool. So yeah. So basically, I already ran it. So results are already there. I know the drawbacks of the result and what is needed to be improved. So basically, I'm just installing the Salesforce Lewis, which is nothing but uh, a library for image transformers, which is built by Salesforce. And I'm taking a data set. These are normal things. So I'm okay. Okay, cool. So yeah, so basically we just install the necessary packages and install the PyTorch transformers, everything, etc. So in this Lewis, right? I mean, my pronunciation is damn. Uh, so basically, there are a couple of models it just supports. For example, blip and other things it supports, where you can see the type of it. For example, we are using blip feature extractor. So basically, base model feature extractor is nothing but when I pass a text and image, so that in between you have to don't want to calculate the embeddings. It automatically gives it, so that I don't want to calculate. It's a very good package. Maybe you can also use it. There are support for also clip feature extractor. You can also play with it. But in this, I use blip because it's good. So yeah, whether it has GPU, etc. I'm using. If you notice, I use Google translators, right? Because why I'm using it? Because to translate, when I get the data set, right, sometimes the data set is not so good, so I translate the whole thing to, even it is in English, I'm translating it. So sometimes you will have like um, German or French words, whatever. So that is there. So this is the multimodal thing which has the image and parallelly the text of it. So I'm just only taking 10 samples and running it, so making it as a standard, converting the image. So um, this and all, you can skip it. So basically, I'm just what model I'm using. I'm specifying it and what model type, etc. So specifying it, and yeah, same thing. So now only I'm creating embeddings for it. So if you look inside it, I'm creating three embeddings. One is multi-model embedding, text embedding, and image embeddings. So I create for all of three, and store it. Okay. Um, yeah, that's it. And now you just store it and everything, make it as an embeddings and store it. And now we are going for the search part. Okay. So I'm writing a helper function for the search. Uh, Helper function for the search, and I also define different modularities. If you see image, if I give an image, so it expects only the text part. For example, text to image, if I give an input as text and image, what is m means, if I will give both the image and text, and it should give me an image. So that is only m stands for both the inputs, other things are single inputs. So yeah. So for example, if I this is the image actually. For example, you have a black pan. So I'm searching by image. Okay. So it gives whatever the data set it has, right? So at least similar kind of a black pan, it able to at least somewhat, it's able to search it. But for sometimes if I search for image to image, right? For example, image to image, it is showing me exactly all three or four of them as white shirts. I'm saying this model which is not trained on the specific data set. These models needed to be trained for a perfect retrieval. I'm just putting a random models from somewhere and random data sets from somewhere and trying to show it, which is not a proper way to do it. Okay. You have to train these models, and these models are easy to train. You can just do it in Colab itself, and you can get all the information. And someone would have done it for in Kaggle, so you don't want to do it. Mm. Exactly. So, but when we go for the multimodal, mm, no difference. What are searching? For example, this image, right? For the black pen, it just the person is not wearing a black pen. Yeah. Now, both are image to image searches. Image to image searches, it works flawlessly. Cool. So when I change the modularity, right? When I change the modularity as mm means I'm saying like I'm giving both the image and the text of it. I'm searching for the same white image, white T-shirt, but it's not showing white. So that's what I said. It's not good. Okay, even I'm searching for a okay, searching for a wrong thing. It's just white image, white T-shirt. So Hmm. Yeah, because you're saying the white T-shirt instead of it showing black image for multi-model. Because right, this the blip model is not like a, universal model where you can do it like ChatGPT or whatever. Okay, they are much more efficient in handling. For example, I'm introducing a new data set which is not trained. So if you can create embeddings in any model, if you any transformers, it will do it. Any encoder transform, but the way they train it right to make club the images together each other, so that's what I'm saying, like it's not so efficient for a multi-model search. So basically the image I gave is white image and give the same thing, it's not retrieving the correct image. Because white t-shirt have a higher weightage than the white, that's the reason it will be having retrieving the t-shirts irrespective of whether white or black. I'm not, I can't prove it to be honest. Because if I give there's another example, I'm giving a shoe. So if I'm having a shoe, so it's imaging. So basically, the data set is not a product data set I'm giving. So that's also because I'm just because I usually will just snap a picture from here, right? So you will not give a proper lighting angle and everything. So so basically for these things, right, you have to train this model with the whatever input you are expected and whatever output you are expected. So these models are easy to train. I'm just giving an example. So you want to say, eh, yeah, exactly. For example, you're saying like if I'm giving an input, I'm expecting an output. You should know, right? It's trained on a different data set, and I am giving a unknown information to it and asking to make it work, right? It doesn't work like that. For example, if you go for the, I'll show in another example, like you have like a multi-model, like chatty multi-models like Lava, so which is much more better in chat conversationals, but not in retrieval. So basically, you have to train these models with the data set what you are giving. I giving a photograph of a shoe, right, which is not even an input which is in that data set. So I'm just randomly chunking out the embeddings and giving some input and retrieving it to say to validate the base level retrieval. So you have to train it at the end of the day, and it can be trained easily. So it's not like you need some 8, 10, hey 100 GPUs like 4 to 10 or 15. So it can be trained. So you can do it in Colab itself. So, but I'm lazy to do it. So it will be a second part. So okay, so I think okay, we are already off time, but I'll just show a couple of things maybe for the second thingy. So give me a minute. Damn, lot of things, man. Give me a minute. So I lost the where is PPT slide? Sorry, I lost the window somewhere. Maybe we'll skim it to the last part actually. So yeah, demo was done, and there is also a conversational part, right? No one asked, man, you said conversational. You didn't see anything about conversational, you're still searching about search. Ah, smart person. So what is a conversational is nothing but like if for example choosing a better model. I said like I use Blip 2, which is not a very conversational model, but it is good at retrieval. How I found it because I'm started to search with this Lava model and it's not giving me good results. Someone from community said don't use Lava, just use Clip or Blip. They're good for retrieval. So so yeah, choosing a better model and having a conversational history handling is make it the search become conversational. The take context and it the chatty models like Blava make it conversational and so maybe you can also implement the rack part, etc. And there is also a Llama index, O Llama using this Lava models. You can also run it. It's very easy. So basically, if you give an image or something from the catalog, like it can retrieve, but for their data set it works. For my data set doesn't work. So still there is some gray area to it. But maybe you can try it and maybe scan this QR code. You'll just get all the referral rings and everything. So just don't want to. This is the both the search and the llama index and the reference whatever I used, and what others. Yeah, maybe I'll show it again. Maybe. So maybe people scan. We can have a QA. So no, it is second part too. So basically, that's what I'm saying. Like in second sessions, right? We'll just train this model and make it retrieve it better and make it how can we can make it conversational. So we are still not made it conversational if you the results are not so good. So any other questions? Yeah, I didn't use any kind of generative. It's just an image retrieval, multimodal image retrieval. For example, if you see the this lava model, right? So basically, there is little bit chatty. So basically, it can text generation. They are good. If you go to the Hugging Face and search, like it's little chatty compared to the Blip 2. So these models can be more conversational. So you can use this kind of models, and the image retrieval part is not so good. That's a downside. Maybe you can also try to run it, and the in the repository I'll get the link. Actually, it's a cookbook. So okay, no QAs, questions. Damn, I'm so good at explaining. So no questions. Yeah. Okay. Awesome, man. Thanks for the Geek Night.
Thanks, Sam. It was quite intuitive, as you mentioned in your title. All right, we will have a quick break before we move to the second talk. And before you go for the break, I have a small ask for you folks. For those who don't know, I'm Vignesh.